Have you ever thought about how an ambulance sounds higher to you when it approaches you, when it's driving towards you, but sounds lower when it drives away from you? And I don't mean how loud it is, I mean the sound that it makes. When it comes towards you, you hear this mee-moo, mee-moo, and when it drives away from you, you hear this mee-moo. Have you ever stopped to think, what is going on? This is not magic. This is not your ears playing tricks on you. This is the Doppler effect. It's science. Remember, sound waves are created by the vibration in a particular medium like air or water. Sound's a longitudinal wave, and they propagate through the medium. So here you can see a little sound source, so maybe a siren or a school bell or something like that. And here we can see the various waves that are emitted. This one is the first wave that's emitted, the one that's furthest away from the source. And then this is the second wave that's emitted, and the third wave, the most recent wave that's emitted. And the waves are continuously emitted as the source is making a sound. Now, you should remember this formula from grade 10. We can use this formula to help us calculate one of these three variables. Remember, this V is the speed of sound measured in meters per second. Now, usually in the Doppler effect, we give you this variable over here, and it's usually around 340 meters per second, although this can vary depending on where you are. F, as you should recall, is frequency. And frequency is measured in hertz. Now, you need to remember, and I hope you do, that frequency is related to pitch. So the higher the frequency, the higher the pitch. And the lower the frequency, the lower the pitch. Frequency and pitch are directly proportional. And then we have this variable over here, which is wavelength. And in our formula, wavelength is measured in meters. So wavelength represents the distance between the different wave crests. So for example, this distance over here would be the wavelength, let's call it x. This distance over here would be the wavelength, let's call it x, and so on. Okay, so that's the wavelength. One important thing for you to remember to understand the concept of the Doppler effect is the bigger my frequency, so the bigger I make frequency, the smaller my wavelength goes. Because V is constant, the speed of sound in air, we're going to take as a constant. So if your question tells you that the speed of sound is 340 meters per second, it's going to stay 340 meters per second for the question. So the bigger the frequency, the smaller the wavelength. And the smaller the frequency, the bigger the wavelength. This sort of relationship is known as an inversely proportional relationship. So I know my drawings are a little bit wonky, but I hope you can see that. Remember the distance between these crests. So this distance here, I'm writing it in purple, is the wavelength. So sound source number 1 has a much smaller wavelength than sound source number 2. Look at this wavelength. This one compared to this tiny little one over here. So this is a big, sound source 2 has a big wavelength. And what you can conclude based on that is that